Welcome to my channel! Learn with Teacher Ali!
Mathematics, Grade 5. Quarter 1, Week 7. Learning competencies and objectives. Lesson objective number 1, identify the height of a parallelogram, triangle, and trapezoid in different orientations. Lesson objective number 2, find the area of a parallelogram, triangle, and trapezoid in square centimeter or square meter using formulas. Our content is about base and height of a parallelogram, triangle, and trapezoid, and formulas for the area of parallelograms, triangles, and trapezoids. Day 1. Now let's have our activity number 1. Review on parallelograms, triangles, and trapezoids. Now students, you need to complete the table. Now, finding areas without grids and in different orientations. For this week or lesson, you will find the areas of parallelograms, triangles, and trapezoid in different orientations as shown in the new figures. Our objective of the lesson is to identify the height of a parallelogram, triangle, and trapezoid in different orientations, and find the area of parallelogram, triangle, and trapezoid in square centimeter or square meter using formulas. The figures could be covered by smaller squares. A single square is a square unit, while the one side length of a square unit is what we call a linear unit. The length is the number of linear units of the longer side, while the width is the number of units of the shorter side. The area is the number of square units that cover the surface of the figure, and a triangle is a three-sided polygon. As you can see on the picture, this is the example of parallelogram. A parallelogram is a four-sided polygon with two pairs of opposite sides parallel, while a trapezoid is a four-sided polygon with one pair of opposite sides parallel. Triangle. The length of a perpendicular line segments from a vertex to the opposite sides. Parallelogram and trapezoid. The length of the perpendicular line from the baseline to the line parallel to it. Day 2. Our topic is about heights of parallelograms, triangles, and trapezoids. Now let us draw the height of the triangle. The length of a perpendicular line segment from a vertex to the opposite side. Now students, is the height identified earlier is still the height of the triangle? The height of triangle is dependent to which side is considered the base. All three sides of a triangle can be its base, hence it has three heights. Now, identify the lengths of the base and height of the given polygons in the first column. Triangles, parallelograms, and trapezoids also have bases. Hence, heights are also dependent on which side is considered the base. The height of the parallelogram and trapezoid. The length of the perpendicular line from the baseline to the line parallel to it. Now, identify the lengths of the base and height. The trapezoid is different from triangles with 3 heights and the parallelograms with 2. Trapezoids only have one since they only have one pair of parallel sides. The height of trapezoid RITQ is the length of the line that is perpendicular to both sides RA and PQ. Trapezoids only has 2 bases, side RI and PQ. Side RQ and IT can't be bases since the 2 sides are not parallel to each other. And the trapezoid RITQ only has one height. The height remains the same regardless of the base being side RI or PQ. Now, students, identify the lengths of the base and height. Now, our activity number 2 is about heights of parallelograms, triangles, and trapezoids. Now, students, complete the table. Day 3. Our topic is about areas of parallelograms, triangles, and trapezoids. Activity number 3. It is about formulas for the areas of parallelograms, triangles, and trapezoids. You need to complete the table. Now, let us find the area of the parallelogram. The given are, the base is 20 cm, the height is 12 cm, and our formula is area is equal to base times height. So, 20 times 12 is equal to 240. Therefore, the area of the parallelogram is 240 square centimeters. Now, here are example number 2, which is finding the area of the triangle. Our givens are, the base is 16 cm, the height is the 15 cm, and the formula for finding the area of the triangle is A is equal to base times height divided by 2. So, therefore, A, 16 times 15 is equal to 240, and then 240 divided by 2 is equal to 120. In that case, the area of the triangle is 120 square meters. Now, let us find the area of the trapezoid. The given for the base 1 is 18 feet, for the base 2 is 12 feet, and the height is 8 feet. Now, for the formula is A is equal to base 1 plus base 2 multiplied by height divided by 2. So, 8 plus 12 times 8 divided by 2. So, the answer is 20 times 8 divided by 2. So, 20 times 8 is equal to 160. And then divided by 2 is equal to 80. Therefore, the area of the trapezoid is 30 square feet. Now, students, try to find the area of the following figures. Day 4. Area of a trapezoid. Now, students, find the areas of the following figures. Day 5. Now, perform the following task. Find the area of the figures using the formulas.
Thank you for watching! Also, don't forget to like, share, subscribe, and click the notification bell for you to be updated on our latest videos. See you on our next lesson. Goodbye!